All right. So OpenFlow is currently the hot topics in networking. Very hot topic. And so we'll talk about 6 different things. Planes of networking. Then we'll talk about OpenFlow. How does it operate? Who implements them? How it has evolved? And what are its limitations? Oftentimes when people talk about OpenFlow, they talk about SDN and NFV. I'm not going to talk about them in this module. They will be talked about in later modules. So this is plain OpenFlow. And we go on to the next protocol, which is the configuration protocol. OpenFlow, yeah. And the project, okay. Can you hold on to the project question maybe after this lecture is done? Okay. Any other question on this lecture? So configuration protocol. So this is a protocol, the protocol that we talked about before about the table lookup and stuff, etc. That is what is called OpenFlow. But in addition to OpenFlow, there is one more protocol, which is this configuration protocol, which is very much like your DSCP and other things, where you tell the switches whom to contact. So there is something called OpenFlow configuration point. Now this is a separate function, which is separate from the controller. But the functions, as we said before many times, can be in the same box. All right. So this is a function, and its job is to simply do the configuration. And the OpenFlow controller's job is to speak the OpenFlow protocol with the switch. So that is the controller function, and this is the configuration function. So the control point is the entity that configures the OpenFlow switches. And what does it do? It basically speaks the protocol which is called OF-config. It's a different protocol with a different specification. And it assigns things like what is the IP address of the controller that you need to talk to, what is the port number on the controller that you need to talk to, whether you should use TCP or secure TCP. TLS. What is TLS? Is the transport level security. That is what we call SSL. So TLS or TCP, basically this means secure TCP or TCP. And then configuration of the queues and ports. So then it tells you that how many queues should you have on each port and what the rate should be. Enable and disable receive, forward, speed or media on the ports, and if you should disable some ports, or should enable some ports, or you should run some ports at certain speeds. Anyway, all this configuration is done by this protocol. And one more thing is that the switch does not have to be physical. A physical switch could be many virtual switches. And so we call them logical switches here. So there could be many configuration points for one physical switch. A physical switch is called OF capable switch. It could have many logical switches. As shown here, we have 1, 2, and then ... in between. So many virtual switches. And so the configuration point could say that this switch talks to that controller, this switch talks to that controller, and so on and so forth. So you could have multiple controllers for one physical switch. And we call them logical switches in this thing. Now, so the concepts: capable switch, OF capable switch is the physical switch, can contain one or more OF logical switches. We already talked about that. Configuration point is the service that configures the switch. Controller is the one that controls the switch and speaks the OF protocol. Operational context is the logical switch. So this is virtual switch. And then OF queue are the queues of the packets waiting for forwarding, ports or whatever the ports we talked about. Resources are ports, queues, certificates, tables, and so on and so forth. So now these are the things that come from the configuration. So what is a certificate? Everybody knows what is a certificate? I think we talked about that too. Right? Everybody knows what is a certificate? I don't see many people. Okay. Here's the thing though. It doesn't matter. If you don't know, you should say, yes, I don't know. I mean, and I will explain. Because if nobody says yes or no, I see some people saying yes, but not everybody saying yes, right? So I don't know if you don't know. So please, okay, this is a class. You don't have to be afraid of saying, no, I don't know. Because if you don't say that, then you won't get it. Anyway, certificate is basically what you use in your computer when you want to talk to any website where you want to spend money. They send you a certificate saying that I am Amazon and not something else. You have to check that certificate out, right? So that is the certificate we are talking about, security certificate. And so each switch will have a security certificate. When it talks to the controller can ensure that this is the switch that they need to talk to, and then the same thing, the switch can ensure that this is the controller they need to talk to, and nobody else is taking it, right? This is for security. Flow tables. We already talked about the flow tables. These are where the entries are. And other resources of the OF-capable switches are assigned to a logical switch. And then each switch has an ID called 64-bit ID, which is the 64-bit is the MAC address, and the 16-bit is assigned by the operator. So, we can just, if there is one switch and we are making it into 5 switches, then we will have just 5 numbers for the last 16 bits. So every logical switch will have an ID, which is called data path ID. So just like OpenFlow, OF config is the evolutionary thing. Basically, it keeps changing. And version 1 was based upon OpenFlow version 1.2. And it was limited to ports and queues. Version 1.1 added certificates, security, and even added tunnels. And then it was also retrieving the capabilities of the logical switch. So the tunnels, etc., can be done with the configuration config. And then 1.1.1 is simply a bug fix. 1.2, which has not been published yet. So that basically is going to be doing a little more topology detection and assigning resources logical switches. So we don't know exactly what is going to be in 1.2. OpenFlow 1.4 just came out in October, so this is going to come out soon. Anyway, so the key is there are 2 versions, 1 and 1.1. One version was what we described so far. 1.1 added the certificates and the tunnels. All right, all of these specs are available online. I have given the URLs. You don't have to read the spec for the OF config. They are slightly difficult to read. If I had more time, then I would have gone through the spec here and explained to you how to read them. Then the next protocol is called OpenFlow Notification Framework. It's actually not a protocol, a framework. So one thing which was missing so far was that controller told everything to the switch. The problem was the switch, when it told the controller, there was not enough detail in that, and it was not sufficient. So they have a new spec actually, new spec which is called OpenFlow Notification Framework. It just came out last month or this month or something like that, very recently, the first version of it. And so what is the notification? Notification is event-triggered messages. If something happened that you were not expecting, then you have to tell the boss. That is an event, right? And that is a notification. So notification is in some sense that you were not expecting. You get a message saying that, okay, I'm sick, or my port is down, or, my buffers have overflowed. And the way it is done, and there is a ITU standard for it, which they are following. ITU standard M3702, which basically has, similar to like everything else, has these several TLVs defined, such as some attribute value changed, communication alarm, environmental alarm. Environmental alarm is the temperature, etc. So if the temperature goes up, that is environmental alarm. equipment alarm if something happens to the equipment, QoS alarm like buffering and so on and so forth, or queues length, processing error alarm, something wrong with the computing, and security alarm, state change, and so on and so forth. So any of these things, they are all defined in ITUT M3702. And this works on the publish-subscribe model. Publish-subscribe model means that the switch is the publisher. It says, okay, I have all these information available. Anybody can subscribe. Actually, anybody means whoever is authorized. So anybody can subscribe, which generally is the controller, which will subscribe, and there will be more than one controller which could subscribe to it. And everybody has authorization. So, for example, if some controller tries to subscribe to something which is they're not authorized, they will be refused. But anyway, so there is a set of subscribers and a set of publisher. So you say, well, I need to be notified if there is a temperature alarm or if there is a buffer overflow on, or port 3 or, things like that. Okay. So you just have a set of subscription. And whenever that happens, all the subscribers will be notified. Controller is the subscriber. The switch is the publisher. Switch is the one which generates the notification. And there are hundreds of switches, so there are hundreds of publishers. And there might be 2 subscribers. Is that clear? There are lots of publishers, very few subscribers. All right. Next, pre-existing notification. So now this is legacy. This is how OpenFlow was doing it before. So this does not fit in this new framework. So the new framework just came out, but there are switches already in the field. They would generate these notifications. They do not follow this framework, but these will be recognized because they're just there. And then the controllers have to be updated to recognize this new framework plus the old one. The old ones are old notifications were something called packet in. Packet in is when you got a packet that didn't didn't match anything, then you send it back to the controller as a notification saying that, look, I got a packet and here is the first few bits of this packet. That is called packet in event. Flow removed. If for some reason you didn't have a space for a flow and you removed it or it timed out or whatever, you send that notification. Port status up or down. Error happened. Hello. Hello is basically every so often you just say hello. Echo request and echo reply. This is like a ping. So the switch can ping the controller and the controller can ping the switch. Experimenter, and people could add their own notification. OpenFlow config had the notification too. And those were logical switch instantiation. So if something got created, then they will be notified. OpenFlow capability, switch capability change. Successful OpenFlow session establishment. So I was happy, I was able to connect to the controller. Failed OpenFlow session establishment. I could not connect to the controller. Port failure. Port went down or port came up. Things like that. Anyway, so the idea is previously they had some set of notifications that were not really uniform, that were not following one standard set. And somebody pointed that out to them that, look, there is already this thing which carriers use and you don't have any of this. So now it is a standard. Okay, the question is in the OpenFlow network, can there will be multiple controllers or there is only one controller? Actually, there are multiple controllers. In fact, everywhere I am saying one controller, there might be 2 people standing behind it. So generally everything is done with a standby. So they call it a controller cluster. All right. So even though in all the pictures you see one controller, but if there are actually three real controllers behind, 2 controllers more behind it, right? But in addition to that, you could have more than one controller, because if I have this network and I have divided into 5 pieces, each piece might have its own controller, right? Now each of those controllers will have their own standby copies, but so you could have, that's why we have these logical switches and controllers. So as shown in this picture here, you have multiple controllers, 1, 2, right, shown here, right? and similarly multiple configuration points, and each switch has multiple logical switches. So all that is allowed. And each controller could have a different subset of the network that it controls. Okay, the question is, can two different controllers control the same network? The answer is not the same network. They can control, the answer is they can probably control the same, but you have to define the network. They can control different ports of a switch. Right? So we could divide the switch into half. You control this half, I control this half. All right? Now, so you have to define what you mean by network. So technically, there are different networks. Okay, let me see. You have to define it. Network is defined as the set of resources that one controller is controlling. Right? So that by definition, whatever this controller is controlling is its network. However, that network could include half of a switch, and the other half could be into some other network. So basically, what will happen is each logical switch has complete set of tables. Each logical switch, as shown here, this is one physical switch. Each logical switch has n flow tables, and one group table. This one has n whatever number that is, and flow table. So each logical switch is complete in itself. You could not distinguish, just like virtual machine, you cannot distinguish a virtual machine from a physical machine. So yes, I mean, basically one controller controls one network, and the network could be virtual. In addition, each controller has its replications, which is just totally for availability, totally invisible in these pictures. Now, implementation issues. The thing is that when you want to implement OpenFlow, there are lots of fields that has to be matched, and then there are multiple tables with a lot of entries, and then instructions for each table, and then on the top of that you need this tunneling which have not been touched. VXLAN, by the way, is supreme. Basically, everybody has to implement VXLAN, and then and so all of this, it can take quite a bit of time unless it is automated, and that's the key advantage. And key thing is that if you don't automate it, it is a lot more work than before. Previously, you put this switch, turn it on, and went off. Now you have to worry about the flow, because per flow you are managing, right? And there's a lot of flows. So some people could complain. Now all of this is easy if it is all software, right? Which sometimes it is. But if it is hardware, it is done in the hardware, then basically it's a lot more work. So OpenFlow is not done yet, of course, and there are some things that people would like to have, and that Open Networking Forum is working on. First thing is that there is no northbound API. So just this week, actually, or last week or this month, ONF announced that they have formed a new group called NBI group, Northbound Interface Group. What is northbound? Northbound means going up. So in these pictures, some software piece is talking to this controller, right? And what language are they talking? What can they say? How do they say that, please create a new thing, right? Every controller has its own way of doing it, and that makes it difficult. If every controller has a different language, a different API, then it is very difficult for somebody to write an application that will run on all controllers, right? So we need a standard API, which is called northbound API in this case. By the way, while talking about northbound, what is the southbound API? Southbound is going down. What is the protocol that is spoken going down? OpenFlow. So OpenFlow is the southbound API, which is already there now, right? Then there is east and west API. What if one controller wants to talk to another controller in a different network, let's say that. All right? That we need an API for that. Or what if this controller wants to talk to its own copy? If you want to have multiple controllers, they have to keep in sync. What is the way how they talk? So those are all east and west. Those are called east to west APIs because they go horizontally. All right. So everybody understands north, south, east, and west. Okay, northbound is the API that you speak to the controller from so the one that you use to program the controller. Southbound is the API that, basically the controller speaks to talk to the switch. East and west, actually they're combined. East and west is the API that the controllers will speak to each other. Northbound and east-west? No, you cannot do that. No, the purpose is very different. You cannot go north and then go south. Because the purpose of east-west is just like this. You guys are peers. So when you talk to your peer, you use different types of language than when you talk to your professor. Don't you? When I hear students talking to each other, they will say, every sentence is right? When they talk to me, they don't say that. Exactly, right? So same thing here. East and west is different and north-south is different. It's a different purpose. Actually, in the computer sense, basically there's a different reason for it. Right? So there are different languages. All right. No standard API for east-west. That already talked about. Ability to continue operation when controller is down. So that's another big problem. If the controllers, now thing is we have 3 controllers controlling the same network. Suppose all 3 go down for whatever happens, then nothing can happen. Right? Because all the tables will time out at some point and they will have no flow entries left. And so some people are saying, why don't we leave some brain in the switch so that it can use it? See, the real world, the way it works right now, the real world is that your boss tells you something, but if the boss goes away, you can still continue to use your brain. Right? So we just don't take away the total brain. The boss doesn't have all the brain and the workers have no brain. That is not the situation. Actually, workers have all the brain too, except that when the boss says something, they just do exactly what the boss said. And so they think exactly like the boss. And that's what we need to do, is we need to define somehow control such that it can continue the operation. Okay, moved. Many other packet formats. Now, every time we have a new version of OpenFlow, we add something. So we have added MPLS, we have added IPv6, we have added, so on and so forth. So what about some more protocols? All right. If we want to handle anything else, we need to go to OpenFlow, Open Networking Forum, and say, oh, well, I need to handle IPX, I need to handle DECnet, I need to handle whatever, SNA. So that's not very good. Flow. Now, flow is good because you just do it on the first packet, you decide the entry, what to do, and then you use it for hundreds of packets. But what about the non-flow protocols? So there are many things which do not have a flow, such as request response, such as DNS request. You send a packet, comes back to your response, and that's it, done. 2-packet flow. Actually, it is 1-packet flow, if you just count by direction. So that requires a lot of hit, because those request responses have to go to the controller and come back. Need API to encrypt data plane packets. So many devices today can take an unencrypted packet and spit out an encrypted packet. These are called firewalls, and these are also called, VPNs, routers, and things like that. So how do you do that with OpenFlow? How do you tell the switch to encrypt, to inject packets, to instantiate a service, such as firewall IDS on the switch? So all of this needs to be done. Need to program an abstract view, easy source to destination without knowing the physical network. And second thing is, right now, the people who are using this OpenFlow, they need to know about the interiors of the network. And that was the whole purpose, that you don't need to know about the network. Right? And so you should be able to say, so some people are saying that what we need is a protocol where, or an interface, I can say, well, I need 5 CPUs and the bandwidth between 1 and 2 should be this and that. So you just say it in abstract sense, and then that is translated into the actual network. Right? Right now, in general, networking is just too low level. Think about the doctors who have to think, when they get a laptop, they don't even know what is default gateway. And they have to know that. Right? And so this is the same situation. Here we have to exactly know what is in the physical layer before we can use it. All right, that brings us to the end of this module. The 5 key points to remember are 4 planes: data, control, management, and services. Now, anybody who can explain me the difference between control and management? OpenFlow separates control plane and moves it to a central controller, simplifies the forwarding element. Okay? So that's the second thing we know now, is that the OpenFlow takes out the control plane. Third thing we know is switches match incoming packets with the flow entries in the table and handle it as indicated in the table. The controller supplies the flow table and the other instructions. So now we know what is the flow table. Then many hardware and software based switches are used, including the Open vSwitch. So Open vSwitch is something that you cannot forget. That is so common, just like VXLAN. Open vSwitch is the most commonly used switch. All right, so I want you to just really know that one very well. Then OpenFlow has been extended to IPv4, MPLS, IPv6, and optical network. And there's a lot more to be done. Okay, the question is OpenFlow is the only protocol in SDN? The answer is no. I haven't used the word SDN yet, much. Not in this module. So when we talk about SDN, then I will explain to you what are the other protocols. All right, if not, then basically the reading list. Now there are lots of references all the way through, but I put them in the references here. But the reading list is something that you should really read. Okay? And I expect you to read these 2 books. They are very easy to read. They are available online for you, Safari book. You can read it at your home. And so make sure that you read those books. And then the only thing, basically DVMS is not described. OV DVMS protocol is not described anywhere. So that one is this RF internet draft. Okay? So I have basically removed most of the other stuff that is something that you would read, and I have read all of these, by the way, is all the specs and so on and so forth, and continues the list. But those are, I have put them in the references.